And look, so we now, I'm doing good on time here. All right, I'm gonna go right here if it's okay with you guys. Can you see that okay? Nope. We're gonna go right, this is good, we can compare it to. So here's what we got using 2. Oh yeah?
We're going to go find T, right?
No, it's gonna be built into what we're about to do. Remember how you use the TI 1 prop z int? There's a function in here for a t interval. It's called t interval. Go to your stat menu, and find the one called, it's just called t interval. That's the only thing it's called in your TI. I think it's number 8. It's number 8 on mine.
Number 8 on mine.
There you go. So no, now Linda, you can find that 2.045 if you wanted to. I don't want you to. It's going to be built into this. So we'll deal with that momentarily. So grab that. Now, let me erase this. This is probably going to look a little bit different. Well, no, it does look a little bit different than the 1 prop z int looked like. Because 1 prop z int was simple. You put in the number of successes, the number of trials, and the confidence, and you were done. With this one, it's a little bit different because you have to put a little more stuff in. Now, the first thing it does is it gives you a choice of data or stats. How many of you guys are on data right now? Is anybody on data? Everybody go to data if you would be so kind. Because generally, this is where you're going to be. Generally, I'm going to give you, whenever I can, I'm going to give you guys raw data to play with. Whenever I can. And if I can't give you raw data, I'll give you grouped data. Whenever I can. So if you're on data, you then have to tell the TI where your data is. Well, mine's not in L3, it's in L1. So go ahead and make sure that says L1. Assuming your stuff is in L1. I'm assuming it is. Fair? Good. Frequency, if it's raw data, is going to be 1. Leave that, is it 1 on yours? Leave it at 1. Yeah, leave it at 1. Good enough? All right. Confidence level, 95%, or 99, whatever you want to do. And then just go ahead and calculate it. It's going to take a little bit longer for your TI to calculate the t intervals. But you got to remember, it's computing that terrible, terrible formula from earlier versus the z formula, which is actually very simple. Look at that interval. 0.5166 to 0.5354. It's almost identical to the one we came up with. And it should be. It's a smidge wider. It's a smidge wider. Because we use the multiplier of 2, and it used 2.045. So it's a smidge wider, but it's essentially the same interval. So why teach you this t interval? Why teach it to you? Well, let me give you at least two answers for that. Number 1. Everybody in the real world that has to estimate an average is going to do this if they can. T-tests, T-intervals, the T-distribution is all about averages. That's one good reason to do it, because it's actually used. Number 2, you can use the Z-distribution if your sample size is large enough. So, if you have a sample, I think the old metric that is used is if it's at least 30, I think that's why I stopped at 30. I want to kind of pay homage to that. If you have at least a sample size of 30, then you can use the Z. If it's under 30, you can use the T. Well, okay, so excuse me, if it's over 30, you can use T or Z. If it's under 30, you have to use T. So, in other words, no matter what the sample size is, you can use T. But if it's bigger than 30, you can use T or Z. So if you think about that, that means you can always use T, correct?
Yeah.
So why even talk about Z with these? That's my point, right? My point is, if you can always use T, then T always works. It's like handing somebody a crescent wrench and going, here, this will get that ball off your engine perfectly fine every single time. Okay, great. Now here's another wrench, but you said the first wrench would work every single time. Oh yeah, but there's another wrench. That just causes confusion, correct? That just causes, right, one tool, one job. So if T always works, then let's use T. Thirdly, and this is purely a selfish pedagogical reason, if we use T for averages and we use Z for proportions, that trains you guys what tool to use at what time. If you're estimating proportions, you'll go to the Z. If you're estimating averages, you'll go to T. Pedagogically, it'll be a good memory tool for you guys. Kendra, ask me that question.
Why would you not use T for proportion?
Because you can't. It's estimating averages. It estimates averages. And proportions estimate percentages. And the Z, because the Z is tied so closely to the binomial, he's a perfect estimator for that. T only makes sense because that's what Gossett was trying to do, estimate averages. Fair? So when you're estimating averages, go with the T distribution. When you're estimating proportions, go with the C distribution. That's a way of keeping track in your mind of what you need to do, what you need to use, and what you need to do. Is that fair? I also want to offer you a caution based on the TI right now. Did anybody notice, as you were in this tests menu, there's a bunch of stuff in here. We're going to hit a bunch of it as we go through this course together too. Did you notice, for example, that right above T interval was something called Z interval? Did you catch that? And it would be really nice if that was the one we had to use for proportions, Z interval. That'd be nice, wouldn't it? T interval for mean, Z interval for, that'd be awesome. The problem is, it's not. Go ahead and select that Z interval once and only once. You'll never ever touch it again, I hope. Why will we never ever use this interval? Based on what it's asking you to give.
Because you'll never know your entire population.
Because you'll never know your entire population, which means you can never give it what it's asking for in that second line, which is the population standard deviation. Why would they even offer this as an option? I don't know. I don't have a good answer for that. Textbooks, that chart I just showed you actually had a note. When sigma, did you see that? You might not have caught that. I'm going to put that chart back up. I told you I wouldn't do it, but I'm going to. Just because I'm just so blown away by the lack of logic in this. Oh, yep. Yes. Scroll down again. Oh, here we go. Right here. Sigma node. What the hell? If you know sigma, what else do you know? You know the whole population, which means you know the population's average, so why are you making a confidence interval? You see what I'm saying? It's like the chicken-egg argument. If you know sigma, by definition, you know mu. So there's no error. There's no need to make it. It's just silly at that point, yes? It's like saying, what kind of fish are in Billy Chinook? Are there trout in there? How many trout are in Billy Chinook? I don't know, go catch them all. Okay, we caught them all. Count it, throw them back in. Now I know sigma. Let's catch a random sample and see how many there are. What the hell? You caught them all. Done. Game over. You see what I'm saying? I'm sorry, I'm getting worked up. Sorry. It's just a dumb thing. So that's why we're never going to use the Z multiplier, because we never know sigma. If it's unknown, which it always is, we use T. Boom. So my point about the TI pedagogically is when you're in the TI, there are lots of things that have Z's on them. Take a look again at these, some of these. See that first thing, Z test up there? If you go to Z test, notice what it asks you for. It asks you for a little sigma. Unknown, therefore you can never use that, okay? When you go back, if you find one prop Z test, that was okay. That's going to be okay for us. If you go down here, Z interval, no good. But one prop Z interval is okay. So in other words, anytime you want to use anything with a Z on it in your TI, it also has to have what 4 letters with it? Prop, because prop stands for proportion, which is what you're estimating. Fair enough? That's all I'm trying to get at here. I'm trying to get at the fact that you only use the Z's estimating proportions, but the T's are used for estimating means. Go ahead, please show me.
So what would somebody use those for?
If you're assuming you know sigma. If you're assuming you know sigma. I don't know why anybody does that. There is quite a bit of this course that is annotated. I'm trying to cut that out and replace it with... the coding for this is essentially 1986. It hasn't changed since 86. So I'm trying to teach you what to ignore and get to what you need. I wish I had a better answer to that. I just don't, and I can't mess with it. I wish I could mess with it too, but I can't change the hardwiring of it. So just to learn what to avoid. It's like a pothole, just walk around it. Okay. Fair? Okay, good. Any questions you guys have right